welcome to AP Calc AB BC. This is 2.4 of differentiability and continuity. This is a practice, and I'll be going over questions 1 through 7. Not too many questions today, and we have a topic that is pretty straightforward, and we're just building up on something that we already knew before, and now we're just going to add a new element. And so previously in Unit 1, we've done continuity, limits, and so now not only are we going to, expand upon our previous knowledge, now we're going to add a layer which is differentiability. And so we're going to find points where we have discontinuities, and then we're going to find points which are not differentiable. All right, let's get started. So, quick reminder, when we have a graph, you usually want to read it from left to right. And so, we're asked to find the x values where the function is not continuous, and the x values where if the function is continuous, we're going to try to find x values where it's not differentiable. So we're going to do the left side first, okay? So x values where the function is not continuous. So we're going to look for breaks in the graph. So we're going to go from here, left to right, and you can see here at x equals 0, we have our first discontinuity. Move here to the right, and then we have another discontinuity. If you remember, what is the first discontinuity at x equals 0? Well, this is going to be a removable discontinuity, also known as a hole. And at x equals 1, since we do have a function value, and it jumps from, since we have a different left-hand limit and a right-hand limit, it's going to be a jump discontinuity. So, hole and jump. Now, it doesn't tell us to label what type of discontinuities these are, but it's good to know. It's just good to know, okay? And then right side is asking us for values where the function is continuous but not differentiable. Oh, sorry, I didn't finish the left side, but clearly we can see that there is no other break in the graph when talking about discontinuities. Okay, so we're gonna start, actually before we start the right side, we're gonna briefly go over. So if we have a cusp, if we have a corner, we have a discontinuity, then those are all points where it is not differentiable. It is continuous but not differentiable. Actually, well, if there's a discontinuity, there's no continuity, but it's the point is that it's not differentiable there. But these two, we have continuity, we just don't have differentiability. And so let's again start left to right. So everything's good here, and all of a sudden we get to x equals -2, and we have a cusp. So remember that we have a cusp that is continuous but not differentiable. Also, I would like to make it known that because you have a cusp, that means that your left-hand derivative is not equal to your right-hand derivative. And so that is why it's not differentiable. Same thing goes for a corner. So you have an absolute value graph. This side has a negative slope. This side has a positive slope. And so that is why at that point where the it meets the corner, it's not going to have a derivative because left-hand derivative, right-hand derivative is not equal. All right, let's move on here. So we get here, we get to x equals 0. Like we said before, there is a discontinuity, but the question is asking us for where it's continuous and not differentiable. Move here, and we have a corner. So again, you don't have to know the exact value of the slope, but it's pretty obvious here. This has a negative slope, and the slope right here, is 0. So left hand derivative is not equal right hand derivative. And so at x equals 3, we have a corner, which means that there's no differentiable value there. Okay, question 2, same approach. I'm gonna start with discontinuity first. Left to right, and we have a jump here. So we have a jump discontinuity at x equals -4. We move along. Everything is continuous from there on out. Okay, so our only discontinuity in the graph is at x equals -4. We have a jump discontinuity there. And then for our right side, function is continuous but not differentiable. So we're looking for corners, cusps, or discontinuity. No discontinuity, just corners, cusps. Okay, and so I'm gonna start from left to right. We have a jump here, and all of a sudden we have this corner right here. You can see that our slope is positive, and then our slope is negative as it approaches 0. So we have x equals 0. And it is still continuous, but it's not differentiable, okay? So that's why I didn't include -4. It's not differentiable there, but it has to be continuous according to the question here. If we move on, everything's good and differentiable, and oh wait, get to another corner here. So again, positive slope, then negative. Okay, so x equals 5 is our answer. All right, and last one of these types of questions, I'm gonna start with continuity first, left to right, and we have a discontinuity at x equals -5. Take a moment and think about what type of discontinuity this is. And if you said it's a whole / removable, you would be correct. There's no function value at x equals -5. Okay, we move along. Everything seems good except for that little screen glitch. Oh my gosh. Okay. And then we get to 2, and we have a jump. And so at x equals 2, we have a jump discontinuity. Okay. And then the rest of the graph is continuous. If this screen does that one more time, I'm gonna get mad. Okay. And then continuous but not differentiable. So left to right, that seems good. And we have another corner. So again, our left-hand derivative is not equal our right-hand derivative. So x equals -3 is our first value here. Move on, and then again another corner at x equals 1. And then, sorry, that's not x equals 1. That is x equals 0. and then the rest of the graph is differentiable, is continuous and differentiable. Okay. Now, I'm gonna move on to the test prep. So f is continuous for a is less than or equal to x less than or equal to b, but not differentiable for some c such that a is less than c is less than b. Which of the following could be true? And so we know that f is continuous, but it's not differentiable. Okay, in these types of questions, it's best to try and eliminate answers. And so let's look at A. X equals C is a vertical asymptote of the graph of f. Well, vertical asymptote is something along the lines of this. And so that implies that you have some sort of discontinuity. And the question tells us that f is continuous on the interval a to b. Sorry about that. And so we can eliminate a. Okay, next we have limit of f of x as x approaches c is not equal to the function value of c. Um, and so let me try and think of something. Okay, let's say you have something like this, and then right here you have a hole, and up top you have the function value. So the limit exists, but at that point there's a discontinuity because you have a function value somewhere else. And so again, that is violating our question, which says that f is continuous. And so B cannot be it. And then C, the graph has a cusp at x equals C. So let's try that. We have A, B, and then let's say, well, actually, let me not do that. And then this is our point C. We have a cusp. Well, f is continuous there, is it not? I don't see any discontinuity. Everything is continuous. However, if we remember that cusps are not differentiable, then C is our answer. But let's look at D just in case you're not convinced. D says f of C is undefined. Well, you can easily eliminate that one. F of C is undefined, and f is not continuous at that point. And so none of the above doesn't work because we got that C is our answer. Okay? Okay. Next question. If G is differentiable at x equals C, which of the following must be true? So again, it says it must be true. So it's not, it could be true. It must be true. Given that it's different, G is differentiable at x equals C. Now, if you remember, if it's differentiable, it has to be continuous. And so you cannot have differentiability without continuity, and so statement 1 has to be correct. Number 2, limit as x approaches c of g of x exists. Well, if the function is continuous, then the limit has to exist, right? You can't have some sort of jump here. It has to be continuous in order for it to be differentiable. So statement 2 is also true. The last one, we have limit as x approaches c of g of x minus g of c divided by x minus c. Now, if you remember from a couple lessons ago, we have this formula, limit as x approaches a of f of x, let me zoom in, x minus f of a over x minus a. This third statement looks very similar to this formula. And this formula right here is one of the derivative formulas, okay? And so, if the limit as x approaches c of g of x minus c over x minus c exists, then that is the same thing as saying the limit at g prime of c exists. And so our answer is E, since all statements are true. And then we have 6, which is following. Let h be the function given by h of x equals absolute value of x minus 4. Which of the following statements about h are true? Okay. Absolute value function, we should know what that is, so we're going to graph it. X minus 4. And then we have to also know that our transformations, and so our transformation here is minus 4. We know that that means that we're going to have a shift to the right 4 units. Okay. And so this is what our absolute value of x minus 4 looks like. Okay. Knowing this, let's look at the statements. H is continuous at x equals 4. Well, that's true, right? There's no discontinuity there. So let's check that off. Statement 2, h is differentiable at x equals 4. Well, it's continuous, but there is a corner. So statement 2 cannot be correct. We have a corner, so it cannot be differentiable. And the last question is, h has an absolute minimum at x equals 4, and that is going to be true as seen by the graph, right? Our h of 4 is equal to 0, which is our lowest value on the graph. And you can also just see that visually, right? 4 is our lowest point. So our answer is going to be D, 1 and 3 only. All right, our last question is given as if f is a differentiable function such that f of 2 equals 5 and f prime of 2 equals 7, which of the following statements could be false? So we're given f of 2 equals 5, f prime of 2 equals 7. So again, in these types of questions, we want to eliminate answer choices. Question A, answer A. Limit as x approaches 2 of f of x is equal to 5. Well, it's also given that f is differentiable. So f is going to be continuous, so f's limit at x approaches 2 has to exist. And so this one cannot be false. B, limit as x approaches 2 from the left of f of x is equal to limit as x approaches 2 from the right of f of x. And so we know that this also has to be false. Why? Well, the limit as x approaches 2 of f of x has to exist. It has to be, equal 5. And so this is just saying that the limit as x approaches 2 from both sides is the same. And so we already know that that has to be true, so it can't be B. Let's look at C. Limit as x approaches 2 of f of x minus 5 over x minus 2. So if we remember from the last question, or I think it was the question before that. Oh, goodness. Right here, limit of f of x minus f of a over x minus a as x approaches a. We see this same format for number C. So we have f of x minus, and then f of a is given in the problem, which is 5 over x minus a. So this is saying that our derivative at x equals 2 of f is 7. And again, that is given here. And so C has to be true. So we are left with answer choices D and E. Okay. And our last one is, well, not our last one. Our second to last one is limit as h approaches 0. So we remember this format, right? Limit as h approaches 0 of f of x plus h minus f of x over h. That is our derivative formula for a function. Okay. So looking at answer choice D and comparing it with this formula, we get our f of 2 plus h. Okay, that part is good. The problem is that our function isn't 5. That cannot be our function. If that was our function, then our derivative would be 0. Okay? And we just know that 5 just cannot be the function. Okay? And so D is going to be our answer because the formulas that are used are not equal to each other, right? So D is our answer. But if you want me to check E, I will do so. E is telling us that the limit as h approaches 0, f prime of x equals 0. Well, this one's just straight up wrong. Well, our h approaches 0, but we don't even have an h in our problem, in our function here. And then even if we were to have the correct format, if we find a derivative using limit notation of f prime of x, we would just get f double prime of x. And so E cannot be the answer. There's no format that looks like E, okay? And so our answer is going to be D. All right, I hope this was helpful. Let me know if you have any questions, and I'll see you in the next lesson, 2.5, Power Rule.